Okay guys, so I want to talk a bit about assessment at the start of the class. So for the assessment, it's going to be in two parts. The first part is going to be a written exam. Okay, so that's going to be for 40%. And then the second part is going to be an assignment that you do in the labs and whatnot for the remaining 60. So the 60% component will be due towards the end of the semester. I think on this I've said in week 11. And the exam then we must set a date for. I was thinking kind of week 6, which would be when? So this is week. This is week 3 now, isn't it? So today is week 3. 4, 5, 6. Let's call it 7, yeah. Actually, so that would be the 29th of October. That'll be my plan, that we'd have it at this time. Probably in this room, but not necessarily, but certainly at this time. Do you have a class before this? No. Do you have a class after this? Yes? No? But none of you have a class before this at the moment. Okay. So we could even have a little bit earlier, maybe even at whatever.
Yeah, we have class before this.
You've class before this. Okay. So some of you have class before this and some of you have class after this. Yeah? Somebody has class after this, yeah? Yeah, okay. In that case, so we'll just do it in the time that we have. So now that week is actually for a lot of people that's like that midterm that we don't have, but that's the week that kids are off school. So like if you're going on holidays with your kids in school or something. I mean your siblings, not your actual offspring. That's that week. So we say that then the 29th. Anybody any issues with that? Well, it'll be on paper. It'll involve a paper and a pen. That's as much as we know now. Okay? I'll, once I have it pinned down, I'll maybe give you a sample or something. Okay? Yeah. Now, I have noticed in the labs a tendency for people to, when faced with a problem or an exercise, to go straight to Google and find someone else's solution and then look at that, on a good day for inspiration and on a bad day just to kind of copy and modify and make their own. And that's not how it works. Like that's not the way to go. Typically, when I've set you a task, I've already given you the pieces of the puzzle that you need in different form, and you maybe just have to fit them together and put them together. So often going off and finding someone else's solution for inspiration is not helpful. But on a bad day, you could end up getting done for cheating. So sometimes you just have to work through the stuff and figure it out. No bother. It can be time consuming, but that's the learning experience. That's the point. That's what it is that you're doing. So just be mindful of that. Okay? When I set you something to do, it's because there's something to learn there that's important, and the learning is in the doing. I mean, you could just give you the answer, but there's no learning in that. So that's my advice. If you want to learn how to do the stuff, you should approach it that way. If you don't approach it that way, one, you might not learn, but two, you might end up on the wrong side of the cheating line. And we don't know where that would take you. But it's certainly not a pleasant place anyway. Okay? Some of you are just used to maybe doing things that way, I don't know. I've seen some people in the lab who just can't really program very well. That's something you're going to have to fix. This is a programming module. And if you can't program, it's not the JavaScript that's going to trip you up, it's just the fact that you can't program. So there's a handful of people who struggle with the programming. So you need to work on that and think. You know, it's very tempting to just type and see what happens, but think about what it is you're trying to do. And writing a program isn't like making soup. You can't just take a bit of this, a bit of this, a bit of this, a bit of this, throw it in the pot and stir it around and, you know, hope it all comes out. You know, you need to actually have a plan of what it is you're trying to do. So be mindful of that, beware of that, or you could have some difficulties. Okay? I'll talk you through very briefly the spec for the assignment because a lot of it won't make sense at the moment. I also have a handout which is 2 sheets, so you can pass that around. Again, that might not make much sense today, but while I have them there, I'll give them out to you. And I'll just connect up to the power if I can, so we don't have any more problems. Give me a second. No, there we go. So, hopefully I won't trip over anything and we'll all be fine. So, you're going to make a front end for a website where you can specify a product and order it. And you can decide whatever the product would be. But the idea is that it's customizable. So some ideas, for example, would be a pizza ordering website where you specify the pizza. You say, I want peppers. You check the box for peppers. And where it shows you what the pizza would look like. So the peppers appear. So that's a nice one, where you visualize the pizza and then you send off the order details. The person puts in their name, address, phone number, whatever, and you accept all that. You could have a muffin ordering website, you know, where you, specify you want chocolate or strawberry, whatever, you sprinkles, icing, whatever, things like that. Or a t-shirt, or even a sports shirt. We might have the home shirt, the away shirt. You could specify the name, the number, size, things like that. I've seen people have great success with sneakers that you could customize where you could change the colors of the different parts. Things like that. So I'll show you a few little tricks that you can use, and once you've got those working, you can have a think then about how you might put those together to make the website you want to make. Okay? One of the things you'll also do is you'll check the input to see if it's valid. And that's what we're going to talk about today a bit. One of the main jobs that JavaScript does is it validates input from users. Okay, so, oops, not there. So you might, for example, have, sorry, no, it's in PowerPoint, isn't it? Just see if this is actually synced up. It might not have. There we have it there. So we might have things like you ask someone to put in the phone number. If they put in the phone number and the phone number doesn't look right, you might have some criteria for what a phone number should look like. The text box, the field that they're entering it in, can highlight to say, oh, that's dodgy there, you need to fix that. And then when they fix it, it would go back to whatever it should be. Similarly, you want to visualize the product as they're specifying it and show the price changing as they specify it. So you might have sprinkles, and you see that the price has gone up when you add the sprinkles, and when you add the chocolate sauce. I didn't have time to draw a nice chocolate sauce, I'm sorry. It's gone up to $2.40. So that's kind of the idea. And I'll show you one or two little examples. If we get time, hopefully we'll even show you one today that you could see could be modified to do something like this. Okay? So, so some of the stuff in the specification here won't make a lot of sense today, but as we go through various things week by week, more of it will make sense. So you can be building up pieces of code as well and have a little library of things that you can plug in then when you start to finish off your site. Okay? But I'm keen for you to have a notion at least of what you might do so that you can be working towards it. So I'll put this spec on the blog there. I'll put a link to it and you can download it. Okay? I'm tempted to say any questions, but not having had this in your hand for any length of time to read it, it's probably not very meaningful. But does anybody have any questions at this point? Obviously, when you've had time to read this, you'll have more questions. Not enough of those, no? Okay. That's on the blog anyway, you can download them. I only did 40. There's about maximum 60, but there's never really 60 here, but we'll see. Anyway, so any other questions? Okay. Right. So in the last class, we looked at how you could change an image on a page after the page had been drawn. And that was our introduction to the document object model. And the document object model was like an interface or an interface into the page. And the elements on the page could be identified by name. They have an ID, and you can say get element by ID, pass in the ID of the thing you're talking about, and that's your way then of connecting to that element. And elements have various properties depending on what they are. So text has color properties, height properties, centered property, whatever, all these things. A box, a div would have other properties. Maybe it has a border, maybe it doesn't, maybe it has a background color, maybe it doesn't. We saw the inner HTML property. I have a little example here which is kind of cute, and what it does is it uses the visible property as well as the source property. So what I've done here is I've got a bunch of PNGs and I put them all in the same place on the page. I've done that using the CSS. Anybody want to hazard a guess as to why they're PNGs? No? Yeah, because PNGs support 8-bit transparency. So PNGs support transparency really well. You can't do transparency with a JPEG. If you put 8 JPEGs on top of each other in the same place on a web page, you'll only see the last one. GIFs do support transparency, but it's not particularly subtle. PNGs can support full alpha channels. So what we have here is I have this image and this image, for example, and a nose and a mouth all on top of each other. There's 4 images there occupying the same space on the page. And I've used the CSS to force them to be in the same place. And what I'm doing then is, when I click on eyes, it changes the eyes. Okay. And again, changes the eyes. And similarly, you can have different noses. Obviously, I didn't spend too long on the design of this. And you can have different mouths. Okay? And it cycles through those. So once again, we have an image on a page that's already been drawn, and we're using the JavaScript to interact with the document object model in order to change the images that are used on the page. So we're altering the images. So let's have a look at the source of that. I can make that bigger, can I? So I'm just using this CSS here to force them all to be on the same point, same spot on the page. That's all the CSS is doing, so we don't need to look at that. So this function do eyes, okay? Well, I've named the images eyes 0, eyes 1, and eyes 2. And when you click on do eyes, iCount gets iCount plus 1. So if it was 0, that goes to 1. And then we do get element by ID eyes source, and the source of that is eyes plus iCount plus PNG. This I was talking about last week when I said that you don't actually have to do this business where you create a new image object and specify the source of that new object to be a file name and then assign the source you want to change to the source of the image object you created. You don't have to do that. You can just modify the source property directly. But in many cases, the browser will only go away and get the image then at that point. So if I hadn't run this in my office before I came up here, there's a very good chance that it wouldn't have worked because the Wi-Fi isn't connected up to the internet. And so when I went to get nose 1, it wouldn't be there. I'd have to go away and get it, and it couldn't get it. But sometimes too, a browser will pre-fetch all of the images it needs. Depends. That's what I'm coming to then. Okay? So when you click on this, it adds 1 to it. So it was like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could say, so when you're at 2, right? I've got the eyes are eyes0.png, eyes1.png, and eyes2.png. So when it's 2, if you add 1 to it, you don't want it to be 3, you want it to go back to 0. So I could put in here a line that says, if iCount equals 3, then iCount gets 0. And I'd be grand. However, this mod 3 does the same job. It goes 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. It never gets to 3. Because 3 mod 3 is 0. So it gets back down to 0. So it goes 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. So that's what's going on there. That's what makes it wrap around. That does pose the question, is that a good idea or a bad idea? Over the lifetime of code, most of the work done on it is going to be not in the writing of it, but in the maintenance of it. So maybe this was a bit too cryptic. Maybe it would have been better to say, if iCount equals 3, then iCount gets 0. Maybe that would have been a better way to go, because it was more obvious what's going on. I think the mod 3 is probably okay, but certainly there are times when you can just be too clever and you write code that's far too cryptic. So you have to be careful of that. But I think in this case it's okay. We do the same then with nose count. Except we've only got two noses, so nose 0 and nose 1. If I had noses 1, 2, 3, or eyes 1, 2, 3, 1, 2, 3, 1, 2, 3, then the mod wouldn't have worked, because mod is necessarily going to go back to 0. So if I had 1, 2, 3, 1, 2, 3, and for some reason I had to have 1, 2, 3, 1, 2, 3, then you'd be doing the if I count equals 4, then I count gets 1, for example. You could do it that way. And the mouth does the same thing. Okay? So that's how it cycles round. So 0, 1, 2, 0, 1, 2, 0, 1, 2, whatever. Nose 0, nose 1, nose 0, nose 1, mouth 0, mouth 1. Okay? So that's just as we did with the rollover, and just as we did with the coin toss, and just as you've been doing in the labs with the slot machine. You have images on the page, and you're modifying the source of them. In this case, we get this effect because the images are all occupying the same space on the page, and the eyes have transparency around them. So you can see through the eyes onto the background underneath. You can see through the nose image, through the transparent parts, onto the background underneath. Another property you can change is the visible property. And so here we have a checkbox, and when you check it, it removes the eyes. When you click it, you can turn the eyes on and off. You can make them visible and invisible. Let's have a look at how that's working. So I have a function here called DoVisible, and what it does is it looks at the element called check eyes, and if its checked property is true, then it does this, otherwise it does this. So it modifies the eyes element, and that has a style visibility property, and it sets it to visible, or it sets it to hidden. So very often you have to Google these and look them up. I would have thought visibility would have been true or false, but no, it's visible and hidden. That's something you wouldn't keep in your head unless you were using it a lot. So you have to look these things up. But very often the names of the properties and the possible values that are acceptable in the DOM are the same as the property names and values you'd expect to see in the CSS. Okay? Now, so when you click on the button that does the eyes, it calls the function doEyes. When you click on the function, the button that does nose, it does nose. And here, when you click on the checkbox, it triggers the event DoVisible. So here we have an input, type equals checkbox, ID check eyes. When you click on it, this happens, and then by default, it's true. So it's checked when we get there. Okay? I should point out that you can have JavaScript in the body, and then that code is executed when the page loads. And it's typically only executed once. The page loads once. So that's where you would set up your variables and things like that. So for your slot machine, for example, if you want to add money to the slot machine, in the body of the document, you would put a script that gives you money gets 100. And then that's set to 100 when the page loads. In the header then, you have code that just sits there in functions waiting to be called. And they don't do anything until they're called. When you spin the slots, you're calling a function from the header. In that function there, you could put in that every time you spin, money gets money minus 1, and every time you win, money gets money plus 10 or something. So what you could do then is you could display, using the inner HTML of some element, how much money you actually have. So when you spin the slots, money goes down or goes up. And then depending on your setup then, you'd want to tweak the win values and lose values so that it's interesting to play. Like if you have a 1 in 10,000 chance of winning, then basically you won't ever win. You just run out of money before you win. So also you want to give them enough money to make them keep playing and stuff. So any questions on this anyway? You could see how with this as your starting point, it wouldn't be that difficult to make a pizza. This could be a pizza, couldn't it? Those eyes could be pretty disgusting olives. That could be some sausage. This could be chorizo. And you could turn things on and off. So from this to a pizza is a very, very short step altogether. Okay. And I even have some pizza images made up that you can use if you want. Any questions on that? Okay. So, what I want to talk about now today and probably the next class is using JavaScript for user input validation. So that's another thing we use JavaScript for. So one thing we use JavaScript for is changing the appearance of the page, and user input validation is all about checking what the user has put in and that it makes sense before you send it off to the server. So, for example, if you're booking a flight from Dublin to Madrid, for 2 o'clock, and then you're booking a flight from Madrid to Dublin for 4 o'clock on the same day, well, the web page might go, hang on a minute, are you sure now that's what you want? Instead of just taking your money, it might say, that looks like it might be a mistake. Because, of course, you can't get to Madrid in 2 hours. And anyway, 4 o'clock would even be an hour earlier, so you don't have less time. Similarly, the most common place we see is when you put in your credit card number and you make a mistake. Sometimes it goes, whoop, you're missing a digit, or I don't like the sound of that. Something's gone wrong there. So we're going to look a fair bit at that because that's one of the main jobs of JavaScript. So you enter your data on the page and you might click the button, and then before the web page sends that off to the server for processing, it'll have a look at what you've said. And if it looks okay, it'll send it off to wherever it's going. It goes to a PHP server somewhere probably. That's a whole other module. In this module we just send it off and let whatever the server do what it does with it. If it's not okay, you might say, whoops, I think you've made a mistake there. You need to check this and this and this. And then only when certain conditions are met will it send it off. So in Ireland, for example, mobile phone numbers have a particular format. So there's 083, 085, 086, 087. I'm old enough to have had an 088, but that's long gone. And there's 089, which is mostly for Erasmus students. So if you were in the bar one night and you met one of the beautiful people and this person gave you a phone number, wrote it on your arm, you woke up the next morning and you looked at it and it was like, call me, must meet up again. My number's 081 5512. I mean, would you rush out and book the most expensive restaurant in town and, dig out your nice clothes, and plan for the fantastic evening you're going to have? Well, no. Why not? Well, first of all, there's no 081. That's just totally made up. And secondly, that number is too short. It can't be a real number. That number can't be for real. So, a mobile number in Ireland starts with an 083, an 085, an 086, an 087, and an 089. And then there's 7 digits. No, if you're up the country somewhere in the middle of nowhere, who knows how short their phone numbers are. That's okay, whatever. But for a mobile number, right, you've got your 0, your 8, 3, 5, 6, 7, or 9, and 7 digits. If it's not that, there's something wrong. Okay? So we could write code that checks the phone number, see if it's okay. Some bits of JavaScript I want you to see before we go there. So Parisint is a function that takes a string and converts it to an integer. And that's really important because you remember, I think the very, very first class I was giving out about how JavaScript is a bit too flexible with types. And sometimes, is it a string? Is it a number? Who cares? Does it matter? Well, sometimes it does. So if something needs to be a number, but you've taken it in as input, as a string, then you'd use Parisint to convert it. So if someone is to put in how many shirts they want to buy, if they put in 5 on the form and you bring them into a variable, that's going to be 5, the character 5. It's going to be a string with 5 in it. It's very important, if that's meant to be a number, that you convert it to a number. And you do that using Parisint. You can continue without converting to a number, and you might be all right. It might be okay. Or it might not. So it's safer to force all the things that should be integers to be integers. And Parisint does that job. Note the uppercase I there. So it takes 2 parameters. It takes the string and it takes the number base. So for your purposes, you would say Parisint S10. Because you probably want base 10. Given JavaScript's quite nerdy origins, you can have any base. You can leave out the base, but then you might run into problems. That's one of the number one problems I see, is people just do Parisint X and they leave out the base, and then everything is fine until it's not fine. Because if you don't put in the base, it'll default to various things at various circumstances. You can look that up. So you really need to put in the base or things will go wrong. But anyway, that's Parisint. It takes a string, gives you back an integer. Index of is very, very useful. So index of lets you find the next occurrence of substring in a string. It lets you find where it is. So if you just had a string colon, C-O-L-I-N, if you did index of O, it would come back with 1 because the first character is character 0. So it'll be position number 1. C001. You can also specify the starting point where you want to look for. So if you did, if the string was Cork Institute of Technology and you did index of lowercase o, then that would come back with 1 because it's a lowercase o at position 1 in Cork Institute of Technology. If you specify the second parameter 5, that as well starts looking at position 5. So it'll start looking from 5 on and comes back with 15. Okay? So those are some things we'll see later on. Here's the code then that prompts the user for a number and checks to see if it's okay. Very often you'll have a number of tests that the input will have to pass to be okay. So here, for example, the first test is that it has to start with 08. The second test is that the third letter has to be, so the third character has to be 3 or 5, 6, 7 or 9. And then the final test, all the remaining characters, all 7 of them, must be digits. So this doesn't allow for Americans to give you their phone numbers, where they like to use letters for numbers. Okay? What's very important and what people often get confused about is that if there are 3 tests that the input must pass in order to be okay, passing any one of those tests by itself doesn't make it okay. It must pass all 3. So one strategy is to write a very, very complex if statement that checks to see if the first thing is true, and the second thing is okay, and the third thing is okay, then everything's fine. But that can get quite complex. So another strategy is to go test by test and basically assume that the input is okay. And then test it, and if it fails the test, set the result to false. So it defaults to being okay, and if it fails any one of the tests, it's not okay. And then you just have to make sure that you never, never, never anywhere else set it back to being okay if it isn't. So up here we have our variable, and we have a variable here called valid that's going to tell us whether it's okay or not. So we're creating a new Boolean variable there, note the capitalization, and we're setting that to true. So by default the number is okay and valid is true. We prompt for the number and in comes the number. It's in a variable called mobile num. And so the first thing we do is we check that there's actually something in there. So we check that it's not an empty string and we check that it's not a null string. So if it's an empty string or a null string, well, that's not good. So we set valid to false. So you set it up as true, and if it fails any of the tests, you knock it down. And that'll work provided you don't have code anywhere else that ever picks it back up again. So once you knock it down, it stays down. Next test is it 10 characters long? If it's not 10 characters long, it doesn't matter, it's no good. So that's another test that it's failed. Sometimes it's easier to specify the exact opposite of what you want and slap a not in front of it. Okay? So if it's not 10, that's a problem. Slice is a function that extracts substrings from a string. And it's a tricky one. Do I have an explanation of it there? I don't. I've changed the order of the slides. That's what's missing there. So slice extracts a substring from a string. And you give it two parameters. You give it the starting position that you want to extract, and then the end position plus 1. Like I said, when I'm king, the guy who designed JavaScript will be first against the wall. But so it means that 0, 2 gives you position 0 to 1, which would be the first two characters. So it extracts the first two characters from the string. So the first parameter is the starting point. The second parameter is the ending point, but you go up to but not including it. So it gets a bit confusing at times. So that will extract 08 if 08 is there. So you check to see if that's okay. If it's not okay, it's false. Next up then, we're extracting a slice from character 2 to 3, but that doesn't include 3. So that's just that one character, which would be the 3, 5, 6, 7, or 9. And again, if it's not that, then it's a problem, shot down. Finally, we have a loop that goes from 3 to 10, but never gets to 10. So it goes from 3 to 9. And what this does then is it checks each character to make sure that each character is in fact a digit. So we have a for loop there where the index is n, and we get the nth character using slice n plus 1, and we put that into C. So C now holds the character that we're looking at that particular point in the loop. And if C is less than string 0, or it's greater than string 9, well, then that's not good. That means it's not a 0, or 1, or 2, or 3, or 4, or 5, or 6, or 7, 8, or 9. So if that's the case, then it'll be shot down. So here we have 1, 2, 3, 4, 5 tests, and that's if you don't count the inside of the loop as each one of those being a separate test. We have 5 separate tests that the input must pass. And if it passes all those tests, then it's gone through. But look at the structure here. We start by setting valid equal to true. And then if we have any reason to believe it's not true, then we set it to false. So we're not setting up one big, huge, elaborate test, the result of which is either true or false. I mean, you could write one big, huge, massive if statement there. And I see people attempting that, and it's probably not the way to go. So assume it's true, test by test. If it fails the test, you knock it down, and once it's knocked down, it stays knocked down. It's tempting to say here, for example, and I've seen people do that, it's tempting to say when you're testing for the 08, it's tempting to say, well, if the first two characters are 08, then valid equals true. But no, just because the first two characters are 08, it doesn't mean that the whole number is okay. Just because the first two characters are okay doesn't mean the whole string is okay. So you have to be careful with the logic. So the general format will be set valid to true. If it fails a test, knock it down, it's false. And nowhere should you ever say valid equals true. Don't ever pick it up. Under no circumstances, once it's knocked down, should you pick it up again. No. So I want to preview then what we're going to look at in the next class, which is checksums. Imagine that the beautiful people in the bars copped on that they do actually have to give you a number that looks okay for you to believe them. But suppose you were sick of, getting made up phone numbers. And you land a job as the telecoms regulator. I know, all these different scenarios now. And you decide, okay, I have a plan to stop people being fooled by dodgy phone numbers. So what we're going to do is, we're going to make a rule that says the last digit of the phone number, okay, is equal to the number of even digits in the phone number. So the last digit isn't really part of the number. Now this would be very inefficient because you would reduce the number of possible phone numbers to 1/10. But let's say we were going to do this, okay? So we have this rule that says the last digit must add up to a particular thing. And let's say the rule is it must be the number of even digits in the rest of the number. So if that doesn't add up, then something is wrong. So if we look at 08799966664, we know something's wrong. Someone's trying to spoof you if they give you that phone number. Because 0879996 and 6 and 6, there's 5 even digits there. So the last digit should be 5, not 4. No, I stress this isn't how phone numbers work. I just made this up. But let's say you wanted such a scheme. So now, if someone in a bar just makes up a number that looks like a number, so they figured out like, okay, it has to start with an 087 or whatever, and it has to be 7 digits. But if they just make one up, what are the chances of them getting lucky and it being okay? It's only about 1 in 10. It's complicated by the fact that the number isn't that long, but you could see how most of the time, if someone just made up a number, you'd catch them out. And so that's what a checksum is. It's a number, typically at the end of an input string, that is calculated based on the rest of the input using some algorithm. And if it doesn't add up, if it doesn't match up, then something is wrong. And so the most famous one, which we'll see next week in next class, is the one for credit cards. So the last digit of a credit card is actually a check digit, a checksum. And so you have to do some maths, you have to apply the algorithm, and if the number doesn't turn out to be what it's supposed to be, then either it's totally made up or someone's made a mistake putting it in. It's very good at catching transposed digits, for example. So I think I made the phone number one here in the code. I can show you that. So I'll put a link to this on the blog as well. So you put in a number 087123445. Is that okay? No. So spend your money at Extravision. And 567. That looks okay in terms of the format, but if you click, that's not okay either. If we were applying our super secret phone number checksum algorithm, what should the last digit be? 087123456. So it should be 5. And so then you can go out and book the lovely restaurant. The phone number was legit. Okay, so I'll leave all of those examples. They're already on the blog anyway. You can check those out. So you can use those to build on. And in the next class, we're going to look at different checksums. On the handout there's a whole bunch of them. The last page is really important. The last page there has code that you're probably going to use. So look at the different functions there and get to grips with how they work. Thanks very much.